This video is brought to you by Squarespace, an all-in-one platform for building your brand and growing your business online. This is a universe, not ours, but one remarkably like it. A cosmos filled with galaxies, stars, and worlds, all governed by the same fundamental laws of physics we know today. For billions of years, it stretches and grows as space itself expands and carries its galaxies ever farther apart. But in this universe, the balance of cosmic forces eventually shifts. Its geometry and energy content no longer drive it outward. Gravity begins to win. The expansion slows, halts, and then reverses. Space starts to contract, pulling everything back together. It approaches the brink of a singularity, a point where space and time as we know them would cease to exist. But instead of ending in an infinite point, something remarkable happens. Extreme quantum effects push back against gravity's crush. The collapse halts, rebounds, and bursts outward. From that rebound, a new universe is born. Our universe! And in this scenario, the Big Bang wasn't the beginning at all. According to the standard model of cosmology, our universe began 13.8 billion years ago in an event known as the Big Bang. Space itself expanded from an extremely hot, dense state. And over time, gravity and physics shaped what we see today. This model, combined with Einstein's general relativity, explains some of the most important observations in modern astronomy. The faint afterglow of the cosmic microwave background, the vast web-like structure of galaxies across the cosmos, and the fact that the universe's expansion is accelerating. A phenomenon often linked to a mysterious force called dark energy. Yet, serious questions remain. We still do not know the true nature of dark matter and dark energy, even though together they appear to make up about 95% of the total cosmic contents. But what if there is a simple explanation? An AAM's razor that relies solely on known laws of physics, avoiding the need to introduce speculative particles or forces. A team of scientists from the University of Portsmouth has proposed a bold alternative to the Big Bang theory that our universe may have formed inside a colossal black hole within a much larger parent universe. They began with a straightforward question. What if our universe formed in the same way a massive star collapses into a black hole? To explore their idea. The team ran simulations looking for a model that could resolve some of the inconsistencies in current cosmology. To their surprise, they found that an exact analytical solution describing the core principles of such a process already exists. In quantum mechanics, identical particles such as electrons or neutrons must each have their own space. As in, they cannot exist in exactly the same state at the same time. This rule is called Pauli's exclusion principle. When you try to squeeze too many of these particles into a small region, the rule pushes back. That push is known as degeneracy pressure. The harder gravity tries to crush them together, the stronger this resistance becomes. This is what prevents the cores of white dwarfs and neutron stars from collapsing endlessly and in some cases trigger a supernova explosion. In the team's model, the same effect works on a collapsing universe. As it contracts toward extreme densities, degeneracy pressure grows strong enough to counteract gravity's pull, stopping the collapse before a singularity can form. The result is a rebound, a bounce that launches the universe into a new phase of expansion. To those inside the newly formed universe, this bounce would appear just like the Big Bang. Now, you might say that bouncing universe scenarios have been suggested before. How is this different? Well, this theory works entirely within the known laws of physics, avoiding the need for speculative particles or unknown forces and describes a purely gravitational collapse taking place inside a black hole. While we understand how degeneracy pressure works in white dwarfs and neutron stars, we have no direct observations of matter at the far greater densities reached after black holes form. But rather than assuming that collapse inevitably ends in a singularity where physics stops making sense, the team argues it is reasonable to think that quantum effects could prevent singularities from forming at all. And here's where it gets interesting. The model predicts that ancient relic objects such as primordial black holes or neutron stars, survivors from before the bounce, could still exist in our universe. If found, especially in the early universe, they would be strong evidence for the idea As you know, the James Webb Space Telescope has already spotted surprisingly old, massive galaxies soon after the Big Bang, which are hard to explain in the standard model, but easier if early black holes help them form. It is a controversial view, but the authors believe that challenging long-held assumptions is essential for scientific progress. Meanwhile, new JWST observations of how galaxies spin across the universe may be pointing to the very same conclusion that we are inside a black hole. Before that, let's quickly hear from today's sponsor, Squarespace, which offers the best tools for easy website design. With their AI-backed design intelligence, creating your unique digital identity is fun, effortless, and quick. Their website design system called Fluid Engine lets you customize every design detail with this extremely helpful drag and drop technology. Squarespace also has built-in analytics so that you can easily track who's coming across your new page. Check out squarespace.com for a free trial. And when you're ready to launch, head to squarespace.com/territory to save 10% off your first purchase of a website or domain. A new research has uncovered an intriguing mystery that the majority of galaxies appear to be rotating in the same direction. The lines formed by the peaks here allow us to identify the direction of the curve of the arms of the galaxies and consequently their spin direction. This is significant because in a truly random universe, galaxy rotations should be roughly evenly split between two directions, according to the study's authors. This unexpected finding, which contradicts existing cosmological models, may hint that our universe itself is inside a black hole. To understand this, we need to look at the physics of black holes. When matter collapses under gravity to form a black hole, it creates an event horizon, a boundary beyond which nothing can escape, not even light. Anything that crosses this boundary is forever lost to an outside observer. However, what happens inside the event horizon is still a mystery. This is where black hole cosmology comes in. Also known as Schwarzschild cosmology, it suggests that our observable universe might actually be the interior of a black hole within a larger parent universe. Now consider the Big Bang. The standard model tells us that the universe began as a singularity, a point of infinite density, just like the center of a black hole. If our universe is actually the interior of a black hole that formed in a larger parent universe, it would mean that the Big Bang was not an explosion in empty space, but rather the moment matter collapsed into a black hole, creating a new universe inside. This has another implication. Each and every black hole in our universe could be the doorway to another baby universe. This could also explain why the fundamental constants of nature appear fine-tuned for life, because black holes that create stable universes may be more likely to persist and reproduce through this process. The scientists believe that this idea could explain several cosmic mysteries. For example, black holes are known to have immense entropy, which corresponds to the vast amount of information contained in our universe. Another factor that could play a role in this scenario is in extended theories of general relativity, such as Einstein-Cartan relativity. Torsion is a property that accounts for the intrinsic spin of particles and can influence space-time curvature. Some theories suggest that this twisting effect of space-time could generate a repulsive force at extremely high densities, potentially preventing singularities from forming. If true, this could mean that instead of collapsing into an infinitely small point, a black hole could experience a big bounce where the core rebounds and expands outward, potentially giving rise to a new universe inside. The scientists continued by adding that rapid recoil after such a big bounce could be what has led to our expanding universe, an event we now refer to as the Big Bang. Instead of a singularity exploding from nothing, it could have been a rebirth from the core of a black hole in a parent universe. This theory would drastically change our understanding of cosmic origins, suggesting that the cycle of universes is an ongoing self-replicating process. Another intriguing possibility is that the universe may have a preferred axis. Studies of large-scale cosmic structures suggest a certain alignment in the way galaxies are distributed and move rather than being entirely random. This so-called cosmic anisotropy challenges the widely accepted cosmological principle, which assumes the universe is isotropic and homogeneous on large scales. If the universe does have a preferred direction, it could point to unknown physics at play, possibly related to the way our universe formed inside a black hole. or how fundamental forces interact on the grandest scales. Moreover, the existence of ancient massive galaxies so soon after the Big Bang challenges our understanding of cosmic evolution. But while the universe inside a black hole theory is tantalizing, there could also be a more pedestrian explanation for the unexpected observations. Maybe some earlier measurements of our universe are incorrect, especially the speed at which the Milky Way galaxy rotates. In any case, the universe is turning out to be far stranger than we ever imagined. And the uneven galactic rotations will likely prompt astrophysicists to reassess certain aspects of our understanding of the universe. What do you guys think? Let me know by dropping in your comments below. And as always, don't forget to subscribe to Territory because this is your space.